Good day, Doc Flora. So today we will be solving our given task for our midterm and finals exam. I hope you would understand and like my video. State the domain and the range. Is the relation a function? Item number 3. Set 3, 4, negative 3, 4, 4, negative 4, negative 1, negative 2. You should always remember that the domain is a set of x coordinates and the range is a set of y coordinates. Therefore, our domain will be negative 3, negative 1, 3, and 4. Meanwhile, our range are the following: negative 4, negative 2, and 4. For us to determine if a relation is a function, we must always see that there is no repeated x coordinate or there is no repetition on the domain. If we can see the illustration below, the only repeated coordinate is under the range. So the one that repeats is only the y coordinates. Therefore, the relation on this set of points are relation many to one, therefore it's a function. Complete the following. F of x is equal to negative 3x plus 12. Find f of negative 1. So we would substitute negative 1 to our x variables. So that would be f function of negative 1 is equal to negative 3 times negative 1 plus 12 is equal to positive 4 plus 12. Therefore, function of negative 1 is 16. Graph the equation. The equation is 7x plus 12y equals negative 8. First things first that we need to do is to convert the equation from standard form to slope intercept form. So we would transpose, or we would have the 12y outside and have the 7x transposed with the constant. So that would be 12y is equal to 7x minus a. So we need to extract y, so we divide both sides with 12. That would mean 12y over 12 is equal to negative 7x over 12 minus 8 over 12. So that is negative 7 over 12x minus 8 over 12. So now we have here a slope-intercept form of an equation, which is y equals negative 7 over 12x minus 8 over 12. First is we need to determine our slope and our y-intercept to begin with. So assuming our slope would be negative 7 over 12 and our constant or our y-intercept is negative 8 over 12. If we would divide negative 8 by 12, we would assume that that is a negative decimal lower than 1. So we would plot our base or our intercept somewhere on the fourth quadrant or the negative side, not later than 1. So that's in between 0 and negative 1. And now we would plot our slope. It's a rise over run. So we would rise 7 points and run 12 points. So we would plot here. There is a point 1, 2, 3, 4, 5, and 7. And run through 12 points. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Both both are located on the negative quadrant, which is the third quadrant. So our line resembles or was illustrated in the third quadrant, which is the negative side. So we have here a line going downwards. It's a line going downwards. Write an equation of a line that passes through the point 27, 29, and is perpendicular to the following equation: y is equal to 3x minus 52. So first, we would determine the inverse of the slope, because the inverse of the slope is perpendicular to the equation. So pertaining our equation would be y is equal to 3x minus 52. So the slope there is 3x, and the inverse of 3x is 1/3 x, and the passing through the point 27, 29. So we would solve for our constant, or for our y-intercept. Why? Because we would be using the slope-intercept form of equation, that is y is equal to mx plus b. So we would use our equations to substitute the values. So we have here y is equal to 29 equals 1/3 x. X is 27 plus b. So 29 is equal to 27 plus b. That's 29 is equals to 9 plus b. Transpose 9, or subtract each side by 9. So that's we have remaining 20 is equal b. So we already have our constant, or our variable for the equation. So we have here our y-intercept as 20 and our slope as 1/3 x. So we would substitute that to the slope-intercept form equation. That would be y is equal to 1/3 x plus 20. Write an equation of a line that passes through the point -21, -20, and is parallel to the following equation: 3x minus 11y is equal to 157. So the same thing that we did earlier, we need to locate or to extract its slope passing through the point -21 and -20. So on the given equation, the slope is 3x, so it's no need for us to inverse because every slope is always parallel to the line. So that would be 3x itself. And we would, same procedure, we would use the slope-intercept form equation. That's y is equal to mx plus b. So we would substitute the following values. So -20 is equal to 3x plus b. -20 is equal to 3 times -21 plus b. So that is -20 plus 63. Why is 63? Because 3 times -21, that's 63, and we need to subtract both sides by 63 so that we would get the value of b, and that would be 20. -20 plus 63 is equals b, and that would be 43 equals b. So we would substitute our value. So our slope is 3x and our y-intercept is 43. So that would be y is equal to 3x plus 43. So sketch the graph of inequality. So our equation is y is greater than or equal to x minus 8. First and foremost, for us to graph this equation, we need to determine 2 points, or the vertices. So to determine that, we will just need to determine the slope and the y-intercept, or the base. So in this equation, the slope or the constant will be -8, and our slope is 1. because we only have x, so assuming every variable has a a numerical coefficient of 1, so that would be our slope is 1. So we would plot our negative 8 on on the the y-axis. So we would plot negative 8 and also our slope. So that's rise over 1, rise from 1 point, and also run from 1 point. Following the same procedure, another rise from 1 point and run for 1 point. So now we would be able to draw a line following the points, and it will be a solid line since it is either greater than or equal. So it will be a broken line if it's only greater than, but since it has either equal or greater than, so it's a solid line pertaining that all the values above the line, including the line itself, is greater than or equal to y. So here we have shaded region will be the upper part of the line.